Welcome back. This is MultiSim again, and this is the circuit we built in the last video that simply biases an NPN transistor. The type is a 2N3904. What we're going to do now is we're going to do a different problem. We're going to explore changing the beta values of this transistor. This is what our lab assignment says, that we want to rerun the circuit simulation with beta F changed from 150 to 250 to verify that the node voltages don't change significantly. But we're going to do better than this. Essentially what we're going to do is we're going to scan beta values from 100 to 400 and look at how that actually affects all the different voltages. Let's see how we do that. As you might expect, you actually have to change the parameters of the transistors. Here's the dumb way to do it. If you double-click the transistor, remember go to Value tab and Edit Model, we could go through and change beta ranging from 100 to 400 at a bunch of steps and run this each time and write down the values. But MultiSim lets us do it much more simply than that if we know how. So let's cancel out of that and cancel out of that. Now what we want to do is buried fairly deeply in MultiSim. What we want to do is come to the Simulate tab and simply go down to Analyses. You'll notice that MultiSim can do a lot of different types of analyses on circuits. The type we want is called a parameter sweep, where we're going to change the parameters of a model from one value to another and either print out the results as a table or display it as a graph. So let's click Parameter Sweep. Now this is where things get a little bit tricky. Essentially we want to set the analysis parameters to be not a device parameter. Device in MultiSim refers to the actual physical device, but to be a model parameter because it's the model itself that we're changing. And we want to change the forward beta. So we're going to go down and look at the parameter and try to find the forward beta. Notice that you see a whole bunch of gibberish here, which are just sort of shorthand notations for stuff we don't know what it is. This doesn't help us, so let's go ahead and cancel and get out of that. The way we figure this out is if we double click on the transistor again and go to Edit Model, you see that BF is the name for the ideal maximum forward beta. So when you're changing this, remember that the variable BF is what we want. So we cancel, cancel. Now we can go back to Simulate, Analyses, Parameter Sweep, choose Model Parameter since we're changing a parameter of the model, and choose the parameter BF, forward beta. Note that the present value is 150, which is what we did in the last video. So we're pretty confident we're doing the right thing. Let's start at 100, and we'll stop not at a value of 250, but a value of 400. Notice we're only doing 2 points. We have 301 points if we go stepping by ones from 100 to 400, and that's probably too much. So basically let's step every 5, which would be a total of 61 different points if I have this right. And my increment in fact is 5. And so now I think we're all set. All we have to do at this point is select a DC operating point, since we're not interested in transients, and let's display our results first on a graph. So we'll just click Display Results on Graph. Once we're all set, we click the Simulate button and let's see what happens. Output variables must be set before performing a simulation. Well, that's actually really intelligent because essentially we need to know what we want to measure in order to do the simulation. How do we figure out which of these variables we want to display? Well, they're pretty obvious. We can look at the current, that's I, at various points through the resistors, through different parts of the transistor. We can also look at the voltages at nodes 1, 2, and 3. So let's do that. Let's select the voltage at node 1 and add that, the voltage at node 2, add that, the voltage at node 3, and add that as well. We'll click Simulate to be able to go ahead and see what happens when we create a graph. Ta-da! Look at this. We can see that we can get out the voltages at node 1, node 2, and node 3, nicely color-coded, across the whole range of betas from 100 all the way up to 400. Similarly, we can get this as a table. Let's see how we do that. If we close this, go back to Simulate, Analysis, Parameter Sweep, and instead of displaying results on a graph, display it in a table, and click Simulate. Now we get a large table that has many of the devices we need for each of the different values of beta. Why would we want to do that? Well, the nice thing about the table view is we can go File and Save As and export it in various formats. For example, let's do our Save As window here. And I happen to like comma-separated variable files because they can be imported into a lot of different things. So we'll select a CSV file, we'll export it to the desktop, and let's call it Beta Sweep, and click Save. I've gone ahead and I've closed down MultiSim, or at least hid the window, and opened up our Beta Sweep comma-separated variable file, which opens up by default in Microsoft Excel. You'll see that we have all three values for different values of beta, from 100, 105, stepping in 5, and for each of the nodes we have a voltage at each point. The nice thing about the table view is you can export these files into many different types of applications, such as MATLAB. This is a good place to stop since we've learned how to build a simple circuit and do a parameter sweep to see how things change.